Arduino and Simulink YouTube channel. In this video, we'll build on top of our earlier simulation where we simulated traffic light for the fixed delay. But now we are going to introduce the variable delay, and as you see the background image, we are trying to change the delay using the potentiometer, and whatever the value the potentiometer we are reading, we are trying to represent with the white LEDs, which you can see on the top left corner. Proceed to the next slide. Here our idea is to use three white LEDs to represent the mapped range for the analog read value. Whenever the Arduino reads potentiometer value, the default raw data will be ranging from 0 to 1023. We want to map that range to 1 to 4. Now in this video we will see how to map the range and how to light the LEDs. Now we will update our earlier state flow to accompany the update, so that whenever the user changes the delay using the potentiometer, the new delay will be applied, and subsequently the LEDs will turn on proportional to the delay requested by the user. So let's get this started. This is our earlier model we have developed using the state flow. This is plain traffic simulation without any variable delay by the user. Now we want to incorporate the variable delay. So for that, let's go and change the each multiplication with some new variable called delay. Okay. Now let's change, apply same concept for each of the multiplications. So when we do that, we are changing the transition criteria from one state to another state. We are modifying our temporal logic to use the new variable delay gain. So this multiplies our previous fixed delay of either 3 seconds, 2 seconds, or 1 second. So multiply even this one. Now save the model and update the diagram so that we can assign the scope for the newly added variable, that is the delay gain. So go to the simulation and click on the update diagram. So Simulink updates the diagram and pops up the message. So delay gain. So we are wanting to feed the delay gain as input to the state flow. So leave it at the input. Press OK. Now go back one level up. As you can see here, the Simulink created new input port for the state flow chart, that is delay gain. Now let's move, select everything and move it a little bit left, clear it up. Now we want to feed the analog data. So analog input. We will attach the potentiometer to the second pin of the Arduino. So change it to pin 2 and press OK. Now as we know, the range will be 0 to 1023. Now for that, let's say we will map the range to be now the output, we want to have it as an integer 32. Now the range will be converted from 1023 to 0 to 3, but we want to, if we multiply our delay with 0, our states will continuously change without giving time for the traffic to flow. So we need to update the bias. So whatever the input we will get out of the gain block, we'll up it by 1, so that our range will be changed from 0 to 3 to 1 to 4. Now once we have this, we need to, based on the gain, whatever we are getting out of it, delay gain, we need to control our 3 LEDs. Close this, go back to our slides. As you see here on the corner we have three LEDs, so we need to control them. Now for that what we can do is we need to convert the here whatever delay gain we are getting to the binary representation so that we can control our three LEDs. For that, let's introduce the one more block from the Simulink library browser that we can do from the logical and bit here. So we want to do bitwise operator. So what that bitwise operator will do, it takes input value, in this case, the delay gain, and modifies it. So we want to know whether the value is either 1 or 0. So let's make it. Now this is 1. So whenever we receive the value, we will multiply with the 1 hexadecimal 1. We'll do the same with hexadecimal 2, and we'll do same with the hexadecimal 4. As you see, I'm changing the binary representation, and automatically the number on top of the block is getting updated from this is hexadecimal 1, hexadecimal 2, hexadecimal 4, but is the same as the decimal numbers. Now once we got it, we need to write it to the digital output block. So this is the digital output block. I want to connect it to the in of Arduino. I am using Arduino Mega in this case. So let's put it here. Now whatever value I am getting next, I want to feed it to the 50, and the next I want to feed it to the 48. Now whenever we get it, it will be converted to the this one, but we want to make sure we have the leftmost rightmost bit set to 1. So whenever we receive value 2, the second bitwise operator will result to true, and whenever we use the number 4, the third bitwise operator will work on it, and it sets only the third bit and clears all other bits. Similarly, the second bitwise AND operator retains the second bit and clears all other bits. So we need to convert this one to the boolean. So we can shift it everything by 1 bit, and here we will shift it by 2 bits, so that whenever we receive value 4, the bit will be shifted by 2 and the rightmost bit will be set. So in that case, our 48 pin Arduino will supply 5 volts to the LED. For that, go back to here, and here we have logical and bit. We need to find the block which performs the bitwise shift for us. So that is the last block, that is the shift arithmetic. Get the block, so let's delete these things, connect now. Similarly, move these things to left. Here it is not connected, so delete the existing connection, connect this. Now here we want to shift it by 1 bit right, so select here, in direction will be right and the number will be 1. We want to shift only one time. Here in this case we want to shift the right, but we want to shift it to 2, so press press OK. Now save the model. Now we have prepared our model. Now go back and click on the update diagram to make sure we don't have any semantics and syntactical errors in our model. Now we have received successfully that we don't have any issues in our model. So next we will deploy this model to the Arduino board and we will see if we can control the delay between the transitions from the potentiometer, and we will see how much delay we are applying by using the 3 LEDs.
In this video, we will see how to control the delay between the states using potentiometer. In our earlier videos, we have seen how to read the potentiometer value using analog input pin of the Arduino, and based on the value we are controlling these LEDs. These are in white color. So we have around total 4 values. For 1 we will light first LED, for value of 2 we will light second LED, for value of 3 we will light first and second LEDs, for value of 4 we will light the third LED to indicate a binary pattern. Now as you see, we are lighting the first LED, that indicates our part is at the minimum value. So as you see, our green will stay around 3 seconds and yellow will for 1 second. Now let's increase the potentiometer value a little bit. Probably I will change it to 3. Now as you see, the green light will turn on for 9 seconds and the yellow for 3 seconds. That is closely evident based on the behavior. As you see, the green LED took 9 seconds, after that 3 seconds for the yellow LED. Now increase it a little bit to make the multiplication factor as gain by 4. So as you see, this state should stay more than the earlier time. Here the green LED should turn on for 12 seconds. After that yellow LED will be turned on for 4 seconds. This is how we can change the delay between the states using potentiometer. I hope you enjoyed this video.